Hello everyone, welcome to the video. Today we are going to solve a question, sort an array of zeros, ones and twos. In this question, we are given an array. That array has only three types of elements, 0, 1 or 2. And the ask is that we sort this array. So as you can see in the example, this is the input array and we have to return this array as sorted, which is seen in the output. We discuss the questions of data structures and algorithms on this channel in simplest words with fundamental approach. If you are new to this channel, please subscribe. Alright, let's begin. So first let's note down the key things. We are given an array of size n. The only elements in the array are 0, 1 and 2. We have to sort that and return it. So if we consider our solution as black box, we get the input as array and we have to return void. Basically the same array will be sorted. If we consider the example here, we have, let's say 0, 2, 1, 2, 0. We have to sort this array and it will become 0, 0, 1, 2, 2. And here is the function signature. It will return void sort 0, 1, 2 int array and its size. Alright, so let's try solving this. What is the simplest thing that comes to mind when we have to sort an array? We can use arrays.sort ARR. And how much time complexity will this take? It will take big of n log n. Why? Because internally it would use some efficient sorting algorithm like quicksort or merge sort. But is this the best we can do? If this array would have multiple distinct elements, even then the time complexity would have been big O of n log n. So what is something that we are not using here? We are not using that we have only three distinct elements in the array, right? Okay, so how do we use this information that this array contains only three distinct elements? Let's look at this array. Let's say if I know the count of how many zeros are there in this array, how many ones are in this array, and how many twos are in this array. If I know this count, can I simply use this count to refill the array again? That number of zeros in this array will be filled first, then number of ones, and then number of twos. So we basically need this information as fast as we can. If we ask what is count of 0, we should get it in smallest possible time. Similarly, count of 1 and count of 2. So let's say if count of 0 would have been, let's say 3, count of 1 5 and count of 2 is 7, then if we give the input 0, we should directly get 3. If we get the input 1, we should get 5, and if we give the input 2, we should get 7. What data structure suits this best? Map, right? So we can use map here to store the counts of different elements in our array. We can also use variables here since these are just three, so we could just have used three variables. But let's go ahead with the map so that we learn the concept as well. So what will our approach look like? We'll first store all the counts in map, then we'll fill all zeros, then we'll fill all ones, and then we'll fill all twos. And what will be the time complexity here? Time complexity will be just big O of n because we only traverse the array once or twice. And what will be the space complexity? Space complexity will be big O of 1, even though we are using map, but it will be constant because we will only use 3 keys in the map and it is not increasing as compared to the size of input. Alright, let's now try to see how will the algorithm look. Okay, so first of all, we'll initialize the map with values 0. Then we will iterate over this array. In each iteration, we'll have this element, and for this element, we will update the map with the count. For example, if we have the element 0, then we will update the count of zeros seen so far in the map. Once we are done with this, we will get the counts of 0, 1 and 2 from the map, and now our only job remains is to fill the array. Now to fill the array, we need a pointer that will track its filling. It will move from 0 till end, and we will need 3 loops. One to fill the zeros with which will fill this number of zeros, another to fill the ones which will fill this number of ones, and another to fill the twos which will fill this number of twos. Let us now try to see the working code for the same algorithm. So first we declare a map. We initialize it with values 0 because the counts of 0, 1 and 2 so far are 0. Then we iterate over the array. In each iteration, we have the array element, and according to the array element, we increment the count in map. This is something that we will usually use in multiple questions, iterating over the array and updating the map accordingly. Then once the map is updated, we finally get all the count of zeros, ones and twos in a variable. And now our job is to fill the array. To fill the array, we take a pointer k that will move from 0 till n minus 1, and we run 3 loops. First loop is for zeros and we fill the value as 0. Then second loop is for ones, we fill the value as 1. Then third loop is for twos, we fill the value as 2. You will find the link to this code in description as well. And here is the method increment count in map, which does nothing but simply it gets the value from the map and puts the value plus 1 as in the map. To summarize, we first understood the problem with the example. We got the clarity on what should be input, what should be output. Then we tried to think through the simplest way possible, and we came to arrays.sort, but we realized that it will take big O of n log n time complexity, and we are missing a very important piece of information, that the array has only 3 distinct values. So we used map to store the counts of all distinct values, and then we filled array according to that count. That reduced our time complexity to big O of n, and our space complexity was anyway big O of 1. We finally did the code walkthrough as well, and you can find the link in description. If you have any doubts, etc., please comment on the video, and we'll meet with some other problem in the next video. Thank you for watching.